All right, chapter 11, section 1, the last chapter. Um, Chapter 11 and chapter 10 are very similar to each other, but instead of doing a hypothesis test against some known value or believed value, in chapter 11, we're just comparing it to, in section 1, to another proportion, and section 2, a different mean. So it's comparing two means, you're comparing two proportions. So what we're going to have in here is, this is a question from section 1, this is number 10, and it kind of goes through the different things, so I thought that would be a good one to do. We have a survey, 1,100 adults are asked, are you a total abstainer from, or do you on occasion consume alcoholic beverage? Of the 1,100 adult survey, 360 indicated they were total abstainers. Then they did the survey later. The same question was asked, and so there was a different number, 396. So every time you do a survey, the proportions are probably going to be a little different. Are they different enough to say that, in this case, maybe has the percentages changed over time? And so that's what we have to figure out. Our null hypothesis is always going to be that our proportions are equal to each other. So we're looking at one of these. And then it says, has the proportion of adults who totally abstain from alcohol changed? So it doesn't say, do they think that there's more drinkers now or less drinkers now? It's changed. So we're going to get a not equals to on this particular one. And now we have to get the test statistic. All right. Again, we're going to use the p-value approach to make our conclusions, or how I'd like you to do it. But to find the test statistic is pretty easy. We're going to go to StatCrunch and put in our numbers. We have 360 out of 1,100 and 396 out of 1,100. And our alpha is 0.10. So if we go to StatCrunch, go into the same spot for proportions, proportion stats, but now we're doing two samples, and we have a summary of the data. So it was 360 out of 1,100, and then the other sample was 396 out of 1,100. So again, our differences, this says that the difference between them are 0, which is equivalent to saying that P1 equals P2, because if you subtracted P2 to the other side, you'd have P1 minus P2 equals 0. So saying that the proportions are equal is the same thing as saying that their differences are equal to 0. So we punch our information in, hit compute, and here is our test statistic, negative 1.62 if they're going to 2 decimal places. So let's punch that in. Negative 1.62. And then it says, what's the p-value? This is the one that I want to use. It's 0.1061. So 0.106 to 3 decimal places. And then finally, what's the conclusion? Since my p-value is not lower than my alpha, I would not reject the null hypothesis. So if we do not reject, that means we have not sufficient evidence to conclude that the proportion of adults who totally abstain from alcohol has changed. So there is not sufficient evidence. We did not reject, right? So not sufficient evidence because my p-value is greater than my alpha. Remember, if the p-value is low, the hoe got to go. The null hypothesis got to go. But in this case, it's higher. So we will not reject.